Hello everyone, today we're going to talk about a very important topic in our computer architecture, number systems. So before we start, first of all, let me give you a little bit introduction of what number systems are. They are different ways of representing numbers. So most common number systems like binary, decimal, hexadecimal, and octal, and etc. But in this video, I'm going to show you how to convert from binary to decimal and vice versa. So let's start from the binary system. So what is a binary number system? Binary number system, it consists of only two digits, which are 0 and 1, and it is used only for computers. So why does it have only two digits? That's because, you know, like computers consist of like many transistors, and it only has like on and off condition. So that's why for off, for example, we have 0, and for on condition we have 1. That's why it only has two digits. Any kind of numbers or words, pictures, everything are automatically converted like in binary system for computers. How about decimal numbering system? So decimal number system is our daily life like numbers starting from 0 to 9. So overall there are 10 digits, 7, 8, and 9. So actually there's a clear difference between a digit and a number. So digits can be 10, numbers can be infinitive. So you can have any kind of numbers just by just using these 10 digits. So now, first of all, let's start converting from binary to decimal. Binary, that's the base of 2. Decimal is the base of 10. So in this video, I'll show you two most common ways of converting. The first one, let me call it as A, from binary to decimal, yeah. And the second one is B. Let's have as a first example any kind of like binary system, binary number system. So let's have like 1, 0, 1, 1, 0. So this is a binary. So how do we convert from this binary number system to decimal? In the first method, we will start from these coefficients, from the last coefficients, which is called less significant bit. So the last bit is 0 times, and we get the base 2. Why we get the base 2? Because we are converting from binary, that's why. Then we will we will put powers starting from 0. So here this will be the power of 0, this will be the power of 1, 2, 3, and 4. This plus, and everything we will add all together. The second one is 1 times 2 power of 1, and the third one is 1 times 2 power of 2, plus 0 times 2 power of 3, but anyway it will be 0, yeah. The last one will be 1 times 2 power of 4. So now let's calculate this one. This one will be 0, and this one will be also 0. So the first one is going to be 2 plus this one will be 4. This one will be 2 times 2 is 4, then 8, then 16. So this number, which is 10110 in binary, will be 22 in our normal decimal number. Now, so in this we can represent. How about the second method? The second method is the easiest method. So let's have the same example here. 1, 0, 1, 1, 0. So in the second method, we use 1, 2, 4, 8 system. Why is that called 1, 2, 4, 8 system? We just start from 1 and we just multiply by 2. And for example, here we have like 5 digits here. And we can actually continue until like how many you want. Actually, we have here 5 digits. That's why you can put it one more of them. So 8 times 2 is 16. Then you put this binary number in under this each number. So 1, 0, 1, 1, 0. And wherever you have 1, for example, we have here for 16 we have 1, for 4 we have 1, now for 2 we have 1 right here, yeah? And we just add all of them together. So that's going to be like 16 plus 4 plus 2. As you can see, it's also 22. Very easy method, yeah? I have one more example. For example, yeah, let's have one more example using the first method here, like very maybe easy one, yeah, 1 0 1 1. So using the first method, as I told you, you start from the less significant bit, which is last one. 1 times 2 power of 0 plus 1 times 2 power of 1. Third one, I will not write the third one for now because it will be anyway third one, no, 0. The last one is 1 times 2 power of 3. So the first one will be 1 because any kind of like power of 0 will be 1, yeah. Plus 2 plus 8. So that's 11. Now normal decimal number, it's 11. How about the second way? Using 1, 2, 4, 8 system. So you just put it like however it is written. So 1 0 1 1. So wherever you have 1, right here, you have here, you have here. So 8 plus 2 plus 1, it's 11. So guys, this is how we convert from binary to decimal number. And now in the second part right here, let's start learning from decimal to binary using two methods. So as you already know, decimal numbers, as I told you, that's our normally numbers, right? So as a first example, let's have using the first method here. No, this should be second because we're starting, we're converting from decimal to binary. Decimal as a base 10, binary as a base 2. Let's have any kind of number. Let's say maybe 37. That's our decimal number. So first of all, using the first method, we don't write like 7 times 10 power of something like this. No. It's a little bit different. It is dividing by 2. So now we just divide by 2 until we have 1 in the end. So 37 divided by 2. So how many 2 we have it in 37? Obviously we have 18. 8 times 10, 8 times 2 is 16, and this will be 36. So here we have remainders here. So remainders are important for us, and we just continue until we have left. Until we have left just 1. So inside 18 we have 9. Oh, normal mass here, 0. So we have 4, 8, 1, 2, 2 times 2, 0. Right here, 1, 0. As you can see, we have like the last number 1, yeah. And now in order to represent 37 into binary, we start from the less significant, which is from the last one to the first one. That is 1. We start here, 1 0 0 1 0 1. So 37 in a binary system looks like 1 0 0 1 0 1. How about the second method, which is a very easy method here, using 1 2 4 8 system. As so what do we do here? It's a little bit different from the from converting from binary to decimal. So what do we do here? So we got here 37, and we continue. We just added like what kind of numbers can be members of the sum of 37, and we have to get from the biggest number. So let's have a look right here, like after 8 times 2 is 16, yeah, and then 16 times 2 is 32. So from 32 we stop here. So the first biggest number that can be a member of the sum of 37 is 32. The second biggest number is 4. So plus 4, that's 36. Then the last one is 1. So it's 37 and 37. And wherever you have these numbers, so under these numbers you just put 1. So under 32 you put 1, under 4 you put 1, under 1 you put 1. Other ones will be just 0. As you can see, a very easy method, yeah? So 37 into decimal will be 1 0 0 1 0 1 into binary. As you can see, they are the same. Now let's have one more example, not to make it clear. Yeah? Maybe let's have a little bit like kind of small number, 25. So 25 into from decimal, well, let's convert to binary. Just divide by 2. So you have 12, 24. We have 1 as a remainder, and 2, 6, 12, 0, 3, 6 0 2 1 1. So we stop here from the when we have just one right here, and then we start writing from the less significant bit to the most significant bit, which is 25 in the decimal looks like as 11001 into binary. Now let's use the second method using 1 2 4 8 system. So we have here 25. Then now let's add one more time right here. After 8 times 3 is 16. So 25 will be the addition of which numbers? The biggest one. The first one is 16. Then after that, 16 plus 8 will be 24, right? So that's where we can get 8. Then the last number will be 1. So under this number, 16, 8, and 1, you just put 1. And the rest part will be 0. So as you can see, 25 and the decimal using the second method will be 11001. As you can see, they are the same. So guys, there can be some kind of ways too, but this is the most common ways. Personally, I prefer the second method because that's much easier to learn. So I hope you understand. You answered the how to convert from binary to decimal and vice versa. If you have any questions, you can text me. Thank you.